All right, here we're going to be looking at simple series circuits. We'll go over a few electrical symbols to start with, and these are just kind of the basic ones that we'll be working with when we do our circuit boards. Okay, here we have a DC power supply. We're going to be working with the battery, so we'll have DC current as opposed to alternating current. It's measured in volts, and we use V for the symbol. All right, here's the common symbol for resistor. More recently, they've gone with the rectangle with the two lines coming off of it. That's resistor. Resistance is measured in ohms, and the symbol is the Greek letter omega. And here we have an earth ground, and there are different kinds of grounds. If you're using a car or some type of machinery, then you might use a chassis ground or an antenna ground in other cases. All right, here we have a wire. Here we have connected wires, and we can tell they're connected because they've got those little black circles, those dots on there. That lets me know they're connected. And here we have wires that are not connected. Now, it's most common to put the little arc over it. So you've got that little arch going over it, so it shows that it's not connected. But some schematics will have just wires crossing each other, and it's a little bit harder to tell. But if they don't have the black dot on there, and there's no other explanation, then we will assume that they are not connected wires. All right, here we have a single pole switch. In this case, it's open, so that would be the circuit's turned off. When it's closed, it looks just like a wire. Here we have a light emitting diode, and when we do our circuit boards, we'll be using light emitting diodes. If it doesn't have the two little arrows coming off of it, then it's just a regular diode. And a diode controls which direction current will flow. It only lets current flow in one direction. And so a lot of times diodes are used to change alternating current to direct current. Okay, and here we have a light bulb or lamp. All right, now a series circuit only has one path for current to flow. There's no place for the current to go in different directions. It just has one path, and it doesn't matter how many components we put in that path. Series circuit only has one path for current to flow. All right, now we're going to start doing some math. We're going to start calculating some values. So here we have a simple series circuit. We've got a 12-volt power supply. We've got 800 ohms of resistance, and so I want to know what the current is going through this system. And we're going to use what's referred to as Ohm's law. And I like to make this triangle E over IR. Now here, E is volts, uses the symbol V. I is amperes. We usually shorten that to amps. The symbol is A, and the R is resistance, and the symbol is the Greek letter omega. And the way this works, since I'm looking for the I, I cover the I in the triangle, which leaves me with E over R. So I fill in my values. I've got 12 divided by 800, which equals 0.015 amps. And usually if we have a decimal in front like that, we'll go ahead and change that to milliamps. So that's actually 15 milliamps. A milliamp is 1,000th of an amp. So you just move your decimal 3 places to the right to change it to milliamps, or 3 places to the left to change it back to amps. All right, in this circuit, we're looking for the resistance. We have 10 milliamps, and we've got 12 volts. So the 10 milliamps, to put into our equation, we need to change that to amps. Okay, So if we've got the E over I, we're going to have 12, and then we change the milliamps to amps. We're going to move that decimal place 3 places to the left, which will give us 0.01 amps. So 12 divided by 0.01 gives me 1200 ohms. All right, now this one, we're looking for our volts. So I cover up the V. So that's going to be I times R. Again, we've got milliamps. So we'll move that decimal place 3 places to the left to make that 0.01 times 1,000. And that comes out to 10 volts. All right, now if we have more than one resistor in a simple series circuit, to get our resistance, we just add our resistors together. The current is going to stay the same throughout the circuit, no matter how many resistors we put in there, the current stays the same. Okay, the voltage will drop across each resistor, and we'll get to that eventually where we'll be measuring the voltage drop across resistors, and the voltage drops will add up to the total voltage. But for right now, we're just looking at the totals. So here we've got 1,000 ohms, and we've got 1,200 ohms. So add the 1,000 plus the 1,200. We get 2,200 ohms of total resistance. I cover up the E. Now changing the milliamps to amps, I move my decimal place 3 places to the left. So that's going to be 0.005 times 2,200. And I get 11 volts. All right, now in this circuit, I've got one resistor and I'm looking for the other resistor. Okay, so the first thing that I want to do is find my total resistance. So I cover up the R. I've got 10 milliamps. I move my decimal place 3 places to the left to change it to amps. So I've got 10 volts over 0.01 amps, or you could have 0.010, same thing. So my total resistance is 1,000 ohms. So to get the resistance of that other resistor, I take the 1,000 minus the 600 from the first resistor, and I've got 400 ohms. All right, so using Ohm's law, we can find any of the unknown values. Now we have to have 2 of the values. As long as we've got 2 of the values, we can find that third value. We just simply cover up the one we're looking for, substitute in the numbers, do the arithmetic, and get our final answer.